All right, we are going to be talking about transformations of our parent function. So starting with this first problem, it tells us our parent function is f of x is equal to x. This means I have a slope of 1 and a y-intercept of 0, 0. So if I start at 0, 0 and go up 1 over 1, up 1 over 1, that is this line right here. So this line is my parent function. So go ahead and highlight that on your paper. And now let's see what happens if I change it. If I have y equals 4x, that means my slope is now 4 and my y-intercept is still 0, 0. So if I start at 0, 0 and I go up 4 over 1, that is this graph here. So this is graph A. Now if my slope is 5 over 2x, that means my slope is 5 over 2 and my y-intercept is still 0, 0. So if I start at 0, 0 and I go up 5 over 2, that is this second line on our graph. So this is graph B. And lastly, it says, this part C says g of x is equal to 2 f of x. Well, we know f of x is equal to x, so this really means that g of x is equal to 2x. So that means my slope is 2, and my y-intercept is still 0, 0. So I'm going to start over here at 0, 0 and go up 2 over 1, up 2 over 1. And so this line is graph C. Now, all three of these graphs are steeper than our parent function. And if we look at these values of our slope, they're all bigger than 1. So as the value of our slope increases, that means our graph becomes steeper. All right, let's take a look at the second example. For this one, our parent function is the same. F of x is equal to x. So that means my slope is 1 and my y-intercept is 0, 0. So if I start at 0, 0 and I go up 1 over 1, up 1 over 1, here is my parent function. I'm going to highlight it again. All right. Now A, my slope is 2/3 and my y-intercept is still 0, 0. So I'm going to start at 0, 0 and go up 2 over 3. Up 2 over 3. So this second line here is graph A. Now part B, 2/5 x. That means my slope is 2/5 and my y-intercept is still 0, 0. So if I start at 0, 0, that means I'm going to go up 2 and over 5. So this line right here is graph B. Now, this last one, part C, says g of x is equal to 1/4 f of x. F of x we know is equal to x. So that means that g of x is 1/4 x. Which means my slope is 1 over 4, and my y-intercept is 0, 0. So I'm going to start at 0, 0 and go up 1 over 4. And so this last line we haven't highlighted is graph C. Now what can we tell about all of these graphs? They are all less steep than my parent function. And if we take a look at our slopes, their values are less than 1. So as the value of the slope decreases, the graph becomes less steep. All right, and we are going to talk about the summary question together in class. So I'm going to flip on over to the back side here. All right. So again, let's find our parent function. Our parent function is y equals x, which means my slope is 1, and my y-intercept is 0, 0. So I'm going to start at 0, 0 and go up 1 over 1, 1 over 1. And here's my parent function. I'm going to highlight it in pink again. All right, let's look at A. Y is equal to negative x. This means my slope is negative 1, and my y-intercept is still 0, 0. So if I start at 0, 0 and go down 1 over 1, down 1 over 1, this middle line here is graph A. Now, graph A is a reflection of our linear parent function, and it has the same steepness as our linear parent function, because negative just means the direction. So it still has a slope of 1, but it's in the negative direction. All right, let's look at B. Y is equal to negative 1/2 x. This means my slope is negative 1/2, and my y-intercept is still 0, 0. So I start at 0, 0, and I go down 1 over 2. Down 1 over 2. And I know that this is graph B. Now, what can we say? Graph B. My slope is 1/2, so that is a negative slope, and it is less steep than the parent function. All right, moving on to part C. Again, we have this g of x notation, but we know that f of x is still x. So g of x is equal to negative 2x. So my slope is negative 2. My y-intercept is still 0, 0. So if I start at 0, 0, I'm going to go down 2 over 1, down 2 over 1. And this is graph C. Now, graph C also has a negative slope, but it is negative 2. And remember, when the value of our slope increases, that means it is a steeper slope. All right. And now lines whose slopes are opposite signs and reciprocals are perpendicular. All right. Last one. Now we've been talking about our slope changing, but here we're going to have some shifts up and down. So let's start by looking at our parent function. It's still y equals x, which means my slope is 1, and my y-intercept is 0, 0. So if I start at 0, 0 and I go up 1 over 1, up 1 over 1, here is my parent function. Okay. Now, part A says y equals x plus 2. This means my slope is still 1, but my y-intercept is now 0, 2. So I'm going to start at 0, 2, and I'm still going to go up 1 over 1, up 1 over 1. So if you notice that this slope has the same steepness, it's just been moved up 2 units. So graph A has been translated up 2, and it has the same slope as our linear parent function. Now let's take a look at part B. G of x is equal to f of x minus 3. Now remember, f of x is just x. So g of x is x minus 3. So my slope is still 1. My y-intercept is 0, negative 3. So I go down to negative 3, and I'm going to go up 1 over 1, up 1 over 1. And this is graph B. So now, what's happened with graph B that's different from our linear parent function? It has gone down 3, and it still has the same slope as our linear parent function. So now lines that have the same slope are called parallel.